Thank you. Let's start closed captioning. And let's get going. Like I said, these two problems and one more are the most commonly missed problems on exam number one, so I wanted to go over them. The first one, okay, is a PEMDAS problem, order of operations. Everybody knows that in PEMDAS we do inside parentheses. Okay, it seems stupid. Okay, you go, okay, there goes Foster again talking weird. Okay, but you can't do parentheses, but you can do inside of parentheses. So to do inside of parentheses, okay, 5 minus 11 is -6. That's doing inside of parentheses. The next thing is exponents. So this is 60 divided by 5. Okay, now here's where the issue came up. Okay, this is 36. -6 to the second power is 36, and it's over 12. But please watch. What is the 5 doing to the parenthesis? What's implied there from algebra? Well, multiplication. So remember, that's a basic idea of all of algebra. Anything jammed together is implied to be multiplication unless there's something else telling you to do otherwise. Okay, so these were right next to each other, but there was a plus sign, so you wouldn't multiply them, you'd add them. But these 5 parentheses, these are jammed together, that you're going to multiply them. Even when you do -6 squared is 36, you're still going to multiply them. You're still multiplying 5 times that answer. However, and this is where I caught a lot of people, okay, in the PEMDAS, PEMDAS, okay, we spent quite a bit of time in chapter 1 saying if a bunch of things was a combination of multiply and divide, if you had 3 or 4 or 5 things and they're all multiplying and dividing, then we go from left to right. So left to right means you do these two first. So you get 60 divided by 5 is 12 times 36 over 12. Okay, the 12s happen to cross cancel. Okay, you could have done 12 times 36 on your calculator divided by 12, whatever, you still get the answer of 36. You still get the answer of 36 no matter what. But the key was, this was a combination of multiply and divide. Okay, and there, when it is multiply and divide is combination, you have to go from left to right. Okay, and that was a key idea. Actually, I did it a couple times in chapter 1 when we were going over that. Okay, so that's the right answer for number 2. That's how I got that. It was not some strange fraction where you did 5 times 36 and get like 180, and 60 divided by 180 is a third, and 1/3 divided by 12 is, I don't know what it was. Okay, but that's the correct answer. Okay, this one, same concept. Actually, there's 2 concepts here. First concept, this is absolute value. It always, almost always, 99.9% of the time has 2 parts to it. If I didn't see 2 parts, you lost almost full credit. Bam, right away. Absolute value has 2 parts. And when we were doing a review on Tuesday and Wednesday night, we did a couple of these. Okay, so it shouldn't have been a shock to you to see an absolute value problem. However, what we said was, you have to isolate the absolute value before you split it into two parts. Okay, and here's again is a common mistake. What does two absolute value mean? It means 2 times the absolute value. 2 times. I'm not sure the green's showing up. Okay, 2 times. The only way to get rid of that 2 is to divide by 2, not subtract. That's 2 times something. Okay, again, it's the basic algebra concept of things jammed together imply multiplication, unless there's something else there. Okay, but when they're jammed right next to each other, it's 2 times this. Okay, so anyway, that gives us the absolute value of 3x minus 2 equals, I'm going to leave it as 11 halves. Some people called it 5.5 and worked it out and did just great. It's okay. That's up to you at this point. Now, we've isolated the absolute value. This is going to be a common theme throughout second semester. We're going to be solving weird equations. Weird equations. Equations with square roots in them and cube roots in them and logarithms in them and all kinds of weird things. And the key to all of these is get these weird things alone. Isolate the weirdness. Get it by itself. Then we'll have developed techniques for getting rid of things. All right. The next error. Okay. First error was some people didn't see absolute value as having 2 parts. Second error was people didn't divide by 2. They subtracted 2. How? I don't know, but you did. Okay. Third mistake is you went back to what you were taught in a previous class. Okay. We never, not once did I ever change what was inside. What I said is whatever is inside could be worth 11 over 2, or it could be worth negative 11 over 2. So I wrote the 2 equations. I said 3x minus 2 is either 11 over 2 or 3x minus 2 is negative 11 over 2. Notice I never, ever changed what was inside. Inside didn't change. What changed was the outside answer. We said either the inside, the whole quantity was worth positive 11 halves or was worth negative 11 halves. So the whole quantity was worth positive 11 halves or the whole quantity was worth negative 11 halves. Never once did we change the inside number. Not once did I ever do that. And if you did it, I don't know how you got the homework right. I have no idea. All right. At this point, this is just up to you to solve it any way you want. A lot of people found that it was easier to change it to 5.5 instead of 11 halves. So add 2, so 3x equals 7.5 because you added 2 to both sides. Divide by 3, x is 2.5. Okay, that's one of your answers. Or, okay, 3x minus 2 equals negative 5.5. So, excuse me, if you add 2, I think you get, I didn't do it this way, negative 3.5, I think. Is that right? I better take my calculator. I'm pretty sure it's negative 3.5. Ah, come on, calculator. Okay. And then divide by 3. And you get x is negative 1.66666 Okay. And it goes on and on and on. The proper answer is negative 1.6 repeating. 0.6 is forever repeat. Or some of you know that 0.6 repeating is the same as 2/3 the fraction. Okay, those are the same. 0.6 with a bar over it repeating and 2/3 are exactly the same thing. So one is the decimal form of the other. So anyway, then you bring them all into a big old fat solution set of 2.5 and negative 1 and 2/3. So, and of course, I would put this in the glare. Good job, dope. This is 1 point. So this was negative 1.6 bar. Is that in the glare? Not quite. Or it's negative 1 and 2/3. That's what I was trying to say. Okay. So anyway, this is this problem. There's several errors. First primary one was not seeing that an absolute value splits into two parts, always. There's one exception to that rule. Okay, and we never covered it, and I don't want to do it right now. The other problem was we never changed what was inside. We changed what the answer was. We said whatever was inside equaled the positive answer, or whatever was inside equaled the negative answer. And the work here is a little messy. All right, I need to erase that and do another problem. Any questions on either of those? This problem with absolute values is going to come back and bite us again. So I'm going to keep throwing it on quizzes and possibly tests and stuff like this. You do need to know how to solve an absolute value equation. You do need to know that skill. Okay, can I erase? Anybody yell at me? Okay.
Yeah.
All right. So the next problem that was missed on the quiz, next set of problems that just really sank a lot of students was number 16 through number 18. What it said, solve by factoring. Okay. Now, I'm going to do one and then I'm going to let you guys do one. Okay. Number 16 looked like this. Okay. Our rule for solving a power equation was make it equal 0. Okay. And then you had to recognize that this was a trinomial. Okay. The A was 1. So in this trinomial, AC was negative 8. Okay. And then you had to run through your multiplication tables real quick. What times what makes negative 8 and adds or subtracts to make negative 2? Well, it was negative 4 times 2. And so because this was what I called an easy trinomial, when the coefficient was 1, you could just use those and say x minus 4, x plus 2, because you had a negative 4 and you had a positive 2. Now, this is where I need everybody to stop watching whatever's on TV. Okay, stop eating your dinner for just a second and watch. Okay. We were solving this. We had to make it equal 0. We factored it using the AC, and then several people stopped right here. and y. You haven't solved it. All you've done is factored it. You didn't solve it. Solve it means to tell me what x is. X equals 3, x equals 2.5. So that's solving x. Okay. Solve using factoring. That's what it says. So we use the factoring, but you haven't solved. And that meant people forgot that it equaled 0. And then we said you have to split and solve the babies. X minus 4 equals 0 or x plus 2 equals 0. You solve each one of these babies, x, add 4 to both sides, subtract 2, and put everybody in a solution set. Okay? Just, you don't stop here. That's just the factoring part. You still needed to solve, get x alone. And this is the technique we used. Factor first, then split, and solve the baby ones, and that's your answer. But several people just stopped right here, and that killed you. Okay, you lost the credit for doing this problem. And on some of the other problems, they were more difficult than this. So you lost a lot of points that you should have had. You got points for factoring, but you lost points because you didn't finish the problem. Okay, having said that, I want you to spend a couple minutes trying this problem. This is number 18. And one of the reasons I'm doing this is because your ability to factor is critical for what we're going to learn in a few minutes. Your ability to factor is absolutely critical. If you can't factor, then you can't do what we're going to be doing for the next 4 or 5 days. So this is number 18. We had 6x cubed minus 15x squared equals 9x. Okay, again, this was solved by factoring. So go ahead, I'll pause the video and you guys can work on it for a few minutes. Okay, so the first thing we have to do is we said make it equal 0. So we're going to take away 9x from both sides. The next thing we want to do is factor this. But remember, we had like 4 or 5 different methods to factor. And the first type of factoring I said you always attempt is what do they have in common? What do they have in common? Well, these all have a 3 goes into all of these and an x goes into all of these. So if you pull out or divide out a 3x, you end up with 2x squared minus 5x minus 3 equals 0. So the first type of factoring was what did they have in common? They had a 3x. But you weren't done because this is a trinomial. And so we're going to use the AC method on it. Okay, so the AC here is -6. So we run through our multiplication tables again. What times what makes -6 and adds or subtracts to make -5. Okay, and it turns out to be -6 times 1. -6 times 1. Again, those are, they multiply to make -6 and they add to make -5. So then we say, okay, this is 2x squared minus 6x plus 1x minus 3. Okay, we threw parentheses around the first group, parentheses around the last group, leaving the plus sign in between. We took a 2x out of here. leaving x minus 3 plus, we can't take anything out of there, so we've said repeatedly you take a 1 out. Okay, also leaving x minus 3. Then, because these x minus 3s, remember that was our check. If those weren't the same, you screwed up. But they are the same, so you take the x minus 3 in front, leaving the 2x plus 1 to come together, bring down the 3x, and it equals 0. So, hang on, we're not even close to being done yet. We factored out a 3x in common, but this was a trinomial. So we had to think, oh, crud, how do I factor a trinomial? So this is all my factoring work for a trinomial. But you put it all together, this down here, this statement here that I'm pointing to is exactly the same as this one up here when it equals 0, except now it's all multiplication. It's this times this times this. By factoring it, by using all these techniques, this problem and this problem where I'm pointing are identical to each other. But we can't solve this one unless we have a computer or a calculator. We can solve this one. And so our steps were, we split it up. We say either 3x equals 0, okay, right in the glare, or x minus 3 equals 0, or 2x plus 1 equals 0. Those were the babies. That's the same thing I did here. After I factored it, I took each factor and split it up and said either the first factor equals 0 or the second factor equals 0. Well, this one had 3 factors. Either the first factor equals 0, or the second factor equals 0, or the third factor equals 0. You solve each one. I'm not going to waste your time solving it, but we get x equals 0, x equals 3, x equals -1/2. When you solve each one of those little baby problems, and so you put everybody together in a big old solution set, 0, 3, -1/2. And that's how you do that problem. Okay. Before I open for questions or anything like that, by the way, it's believe it or not, it's called the fundamental theorem of algebra. Woo, it sounds fancy. But basically what it says is, if you have a third degree or third power polynomial equation, the chances are really strong you're going to have 3 answers. Okay, there are exceptions to this rule, and there's reasons for the exception. But if you have a third degree or third power equation, after you make it equal 0, I should do it here. Okay, then you're going to get 3 answers here. If you have a second degree or second power equation, whoops, after you make it equal 0, then you're going to probably get 2 answers, which we did. And if you had power of 1, think about all those problems we did in chapter 1. We got 1 answer, or chapter 2 it was, we got 1 answer. That's called the fundamental theorem of algebra. It just basically is a predictor. Power of 3, 3 answers, most of the time. Power of 2, 2 answers, most of the time. All right, questions on those? Any one of these solved by factoring? People easily could have had 5 or 6 more points on this, except they made some really boneheaded mistakes. It hurt. Okay, I need to erase and move on to actually new stuff finally. Okay, but the new stuff is based on this. That's why I wanted to get to this a little bit. Okay, let's erase then. And I don't want to confuse you, but I'm gonna. Okay. We covered exam number 1. You don't need to write this down. You just need to understand it. Okay, watch. Exam number 1 covered chapters 1 through 7. In most introductory classes, intro to algebra, okay, they all cover chapter 1 through 7. And then there's a chapter 8, which is called rational expressions. And then intermediate algebra covers its own chapter 8 up through chapter 12 or 13. Okay. And also this is most of the time, not all of the time. Depending on the textbook you pick up, it's all a little bit different. Some people put this rational expression chapter over here. Some people put this rational expression chapter over here. Okay. I opted to move it over here with the intermediate. Okay, but that's going to confuse us because we have 2 chapter 8s. We have a chapter 8 that's called rational expressions, and we have another chapter 8 that's called radical expressions. Again, why do we have 2 chapter 8s? Because many textbooks, and I stole a lot of my work from different textbooks and different teachers, put this first chapter 8 over here with the intro stuff. I chose not to. I didn't want to do it that way. So that's confusion. We have 2 chapter 8s. So hang with me for just a second. Okay, I want to go to mom. Is there anybody who can't see my mom page? I've shifted over to mom. Everybody can see my mom. Okay. Yep. We have just finished elementary algebra, and it says keyed to an elementary text, beginning algebra. Now we're going to go into this green bar, which is intermediate algebra, and I've keyed it to an intermediate algebra text. So the reading, whatever videos are there are from an intermediate. So let's open it up. Okay, it says we have 2 chapter 8s. We have an elementary chapter 8, and we have an intermediate chapter 8. Okay, which is what I was trying to explain on my whiteboard. There's 2 chapter 8s. Right now, we're in the first chapter 8. So if you want to find your homework assignments, you're going to go on the first chapter 8, click this, okay, and it opens up, click it again, and there's all the assignments, and they're all ready to go. And they're due in a few weeks, couple weeks. Okay, all of these things. But it's confusing to get there. Okay, and I needed to do a little bit of an explanation. Okay, we have an elementary chapter 8 that probably should have gone up here in the elementary section. I just didn't want to do it. And then we have an intermediate chapter 8, which we'll get to in a minute, in a week or so. So you go into the elementary chapter 8. Okay, it says rational expressions from the elementary text, and there you go, you're doing it. So you should be able to find all the homework, and assuming everything goes well tonight, okay, you should have a lot of homework tonight. Yay, I know for you. Okay. Oh, what time is it? All right, we got time. I want to do a little bit, then we'll take a break, and then we'll do a little bit more. Does my explanation, is that okay? Can you guys find the proper homework on Mom? That's what I'm concerned with. Can you find the proper homework? Do you understand where it is on Mom? Okay, no one's speaking. So I'm going to assume that we're good to go. So tonight we're going to start chapter 8E for elementary. Okay, it's rational expressions. Okay, and the root word, if you look at the root word of rational, it's ratio, and it literally means fraction. A ratio is a fraction. Okay, so everything we're doing in chapter 8 is going to be algebra fractions. Now, we need to clarify this for a moment. This is an arithmetic fraction, okay? 27 over 36. That's an arithmetic fraction, okay? This is an algebra fraction. Okay, I'm going to use sometimes arithmetic fractions to show you the proper way to do a problem. Because, okay, here's the big issue. Almost everybody can do arithmetic fractions. They can reduce them. They can multiply them. They can sometimes add them and subtract them if you remember to get a common denominator. And every student in the world has developed bad habits. Every person in the world, me, other instructors, when it comes to arithmetic, we've all developed shortcuts, arithmetic fractions. But those shortcuts, those tricks, those bad habits can't be used for an algebra fraction. So my job is to try and break you of your tricks, your shortcuts, your bad habits, so that you know how to do this. There's only one way that this problem can be done. Only one way. And I will tell you, for this chapter, 90% of everything requires you to be able to factor. All right. So with that background, you guys understand the difference between an arithmetic fraction and an algebra fraction? We're going to be doing a lot of these. Okay, they're polynomials. Divided by polynomial, we're going to have to factor. So, having done that, we're going to go into chapter 8.1. And the first thing we're going to talk about is how to reduce or simplify a fraction, a rational expression. And here, I'm going to write it down. The key is for you to factor completely. Actually, let me change that. That's wrong. One of the things I noticed on the test is people did the right steps, but in the wrong order. They forgot when I said first, second, third, it means you must do this first. You must do this step second, and you must do this one last. There's a reason I label things as first, second, third, because that's the order in which you attack the problems. So the key for all of these is first, you factor completely. Second, okay, you cancel exact same factors. Okay, and I can't stress that enough. Okay, exact same factors. Okay, if they're not exactly the same, you can't cancel them. Even if they kind of look like, first cousins, you can't cancel them. You can't. They've got to be exactly the same, except there is a trick that we have to worry about, and I'll get to that in a minute, and I'll show you how to find that trick. But let's go back to that example I had up here. Okay, the instructions will say either reduce or simplify, whatever. People can't make up their mind. I think the example I had, wasn't it 3x squared? What was it? 3x squared plus 6x? Was that the example I had?
That's 3x squared plus 6.
Plus 6?
Yeah, no, it's at the end. Yeah, so there was no x.
Okay, that was the previous. I need the x. This one, the one I gave you, wasn't going to be a good problem. I do need the x here. Okay, so 3x squared plus 6x, x squared minus 4, and I want you to reduce this. Well, I'm going to show you how. Okay, if you start canceling the x squareds, you're instantly 100% wrong. Because canceling was the second thing you do. The first thing you do is you factor. Okay, so if we look at this problem and we factor out a 3x out of the numerator, remember they have a 3x in common. Okay, take out a 3x and you're left with x plus 2. Now, the denominator was something called a dose, difference of two squares. Okay, I'm going to show the answer. It's going to be x plus 2, x minus 2. Okay. Does anybody need an explanation or want an explanation of how I went from here to here? Are you okay with dose factoring? Two squares, we separate them out, one's a plus, one's a minus. Is that okay with everybody? Okay, I don't hear anybody yelling. All right, so now, what factors are exactly the same? Well, the x plus 2 and the x plus 2. So those cancel out. Okay, so here is now our final answer, and this is where we're going to have a few issues. Okay. After we cancel the x plus 2's out, the 3x is left and the x minus 2 is left in the bottom. The parentheses are still around the x minus 2. It's still a quantity, but a mathematician would tell you, well, we don't need it for anything. But the beginning algebra student must see those invisible parentheses So they treat this as a quantity. And if you wanted to reduce this anymore, x minus 2 would have to cancel with another x minus 2 on top. Okay? The temptation is to cancel the x's. You can't, because that x minus 2 is still a quantity, even though we didn't write the parenthesis. So the way I like to teach it is I will still keep the parentheses there as a reminder to myself that that's a quantity still. This is the answer. You're done. This is it. This is the simplified version of that problem. Okay. Again, the key was I need to factor first. If you don't factor first, everything else becomes a waste of time. Okay. You must factor first. So you guys try this problem. 2p minus 6 over p squared minus 4p plus 3. And I'll pause for a second. Okay, so in the numerator, I can take factor out of 2, leaving p minus 3. Now, I'm going to show you the answer to the denominator. It's going to become p minus 3, p minus 1. Okay, how did I get that? Because off to my scratch paper, I don't even need to see it anymore. I know that AC is 3. 1 times 3 is 3. So the only thing that multiplies to 3 is 3 times 1. But wait, they have to add or subtract to make -4. So -3 times -1. So because this was a shortcut, I say p minus 3 and p minus 1. That's how I got to that. Okay, AC was 3. Things that multiply to 3 and add to -4, a little trickery in there. Okay, you had to make them -3, -1. So you get this. So who cancels out? The p minus 3's cancel out. So we're left with 2 over p minus 1. And it wouldn't bother me at all if, for safety's sake, you always put in those missing or extra parentheses. Don't have to, but it's safer. Questions? Going once. Going twice. All gone bye-bye. All right. I need to erase this side of the board. Please make sure you have these steps for chapter 8.1, reducing or simplifying. The first thing you do is factor. After you factor, then you cancel. And we'll get to the trick in a minute. Okay, erasing. You know, in previous classes, I had people all over the place screaming at me, go, no, wait, I have a question. Wait, what are you doing? Okay, let's try this one. This will be the last of the nice ones, and then we'll get to tricks. X squared minus 5x minus 14 over x squared plus x minus 2. Go ahead, try and reduce that one. Okay, so for this problem, it's going to be x minus 7, x plus 2 on top, on bottom, x plus 2, x minus 1. Right, and again, I will be happy to show you how I did that. I'm skipping the AC work. Okay, you still have to do it. If you can do it in your head, great. Okay, if you need to do it on scratch paper, great. But the top, your AC is 7 times 2. On bottom, your AC is 2, whoops, times -1. And because those had a 1, we could use the shortcut. You can only use the shortcut when there's a 1 in front of the x squared. So here I factored, so the x plus 2's go away. So I end up with x minus 7 on top, x minus 1 on bottom. Remember, these are still implied to be quantities. So you can't cancel the two x's here. The temptation is to do that, but those two x's, this x minus 7 isn't just x minus 7, it's the quantity. They're tied together inside that quantity. And if you want to cancel the x, you actually have to cancel it with an x minus 7, and that doesn't exist. Okay, so 3 really good examples of reducing or simplifying by factoring. Now, I want to show you a trick, then we'll take a break. And we'll come back and do more, of course. So, questions on these 3 examples. These are really good examples where you have to factor first, okay? Factor what they have in common, factor a difference of 2 squares, factor trinomials, all kinds of factoring are all in the first section that we're studying. Okay, so we're ready for, this is still in section 8.1, and we're still talking about reducing or simplifying, but there's a trick involved. And over the years, I've tried to come up with logical ways of showing this trick. I've tried to show it to you in a strictly algebra way, and when I had classes in person, I could just see everybody's eyes just sort of roll up in their head going, oh, shut up already. If you're not doing it now, okay, I understand. But they're just going, just shut up and show me how to do it. So over the years, I've developed a slightly different way of teaching this trick. Okay, so this is still chapter 8.1. We're still reducing or simplifying, but now we're looking at, I call it the -1 trick. -1 trick. And you don't need these for your notes yet. You don't need these for your notes. Okay. But what if you had 5 minus 2 over 2 minus 5? 5 minus 2 is 3. 2 minus 5 is -3. So it simplifies to -1. Okay, there's a method to my madness. Just hang with me for a minute. Okay, 10 minus 15 and 15 minus 10. 10 minus 15 is -5. 15 minus 10 is +5. But when you reduce them, it becomes -1. They reduce out to a -1. Now, there's a couple things you need to see in this. I'm going to give you the algebra rule in just a second. First off, this only is for negative. It only works if there's negatives. And it only works if all the numbers are same, top and bottom, but they're reversed from each other. 5 minus 2, oops, 2 minus 5. Okay, 10 minus 15, 15 minus 10. So it's got to be subtraction, it's got to be the same numbers, and they've got to be reversed from each other. So just for fun, what if I had 167 minus 52 and 52 minus 167? I just made up those numbers. But the answer is instantaneously -1. You don't have to do any work, it just is. 167 minus 52, 52 minus 167. Same numbers and subtraction, and one of them is the reverse of the other. It will always simplify to make -1. Always. Okay, that's a guarantee. So the trick is, if you are factoring and you have A minus B over B minus A. So if you have two things, somebody on top, somebody on bottom, they're exactly the same except reversal of numbers, the answer will always be -1. Always. That's a real quick, important shortcut. Now, again, I can boggle you with algebra BS, but I don't want to. You got enough trouble. Okay. So let's take this example. Okay. X squared minus 16 over 4x minus x squared. Okay, I'm going to do it right now. Okay, and show you, and I'm really hoping you're paying attention and are asking questions, because there's a lot of leeway in here. There's no one right way to do this. Okay, the top is a dose problem. It's a difference of two squares. So we can factor this as x minus 4, x plus 4. That was easy. The bottom, they have an x in common. So when we factor out an x, we end up with 4 minus x. So that's the first step. You had to factor completely. The top was a dose, DOS, difference of two squares. The bottom was x in common. Now, look at this. 4 minus x, or excuse me, x minus 4 and 4 minus x. Okay, they're not exactly the same, but they are this -1 trick. They will cancel out to make a -1. The question you guys have to ask is, where do you stick it? I know that's vaguely wrong, but where do you stick it? Where do you put the -1? Okay. The answer is anywhere you want. Remember, we've talked about fractions before. We've said if you have the fraction -2/3, that's the fraction, same as 2 over -3. You can move the negative sign top bottom, or you can put the negative sign smack in the middle. When you have a negative in a fraction, you are allowed to move it into anywhere you want. You want it in the numerator, you want it in the denominator, you want it smack out front. Okay. Most people will opt for putting it right in the front because it's easier. So let's do that. These two are going to cancel, but they're not going to cancel completely. They're going to leave a -1 somewhere. Now I put it on top for now, but it doesn't matter. You can come down here and go negative x plus 4 over x. Remembering the top has a quantity around it. Well, so does the bottom, but that's it. So again, that 4 minus x, x minus 4, they cancel, make a -1. The question is, where do you stick the -1? Do you leave it on top? Do you move it to the bottom? By the way, if you did this, you'd be just as correct. If you decided to put the negative sign, the -1 in the bottom, great. Okay, put it in the middle, put it in the bottom. Putting it on top is a little bit weird. I'm not sure well, okay, I'll do it because occasionally mom may get it to you. I think with these two types, you get by with most anything on mom. If you put it on top, oops. If you put it on top, remember it has to distribute through the numerator. If you put the negative sign in the numerator on top, okay, then you have to distribute this to become -x minus 4 over x. You got to distribute it to get rid of those parentheses. So most people, because they're lazy, yay for lazy, okay, most people don't want to put the minus sign on top because they don't want to do the extra step of having to distribute. Most people would either rather stick it in the bottom or stick it in the middle. All right, I'll stop talking. Questions? You're sure?
I have a question.
Yeah, shoot.
If you can put the -1 anywhere, couldn't the denominator be x minus 1?
No, you're multiplying. It's a multiplication. These cancel to be -1, so that -1 is multiplying by that, or multiplying by that, or multiplying the whole thing. It's not subtracting. If you put it in the bottom, you'd be saying the -1 is subtracting. If I heard you right. Okay. If those cancel and you get this, you're saying, can you put the -1 in the bottom? And now all of a sudden you've turned it into a subtraction problem when this -1 is actually a multiplication. -1 multiplied with that. Okay. So no, you can't just stick it in the bottom. You have to multiply it together. Now, if you multiplied it, x times -1, that's how I got -x. But I didn't subtract it. Did I answer your question or not?
Yes.
Okay. All right. Good question, because we got all these crazy math symbols and rules and stuff like that. So it's hard to keep everything straight. That was a good question. Good clarifying question. I like it. Anybody else? Okay, let's do one more. Okay, you guys try this one. 9 minus x squared on top and x squared plus x minus 12 on bottom. Do a pause. Okay, so the numerator is a dose. It will become 3 minus x, 3 plus x. Again, guys, if you need me to show you my work, how I went from here to here, I will be happy to show you that. Okay, don't let me talk so fast that I overrun you. Okay, the denominator is an easy, what I call easy trinomial. It's x plus 4 and x minus 3. Again, AC is negative 12. What multiplies to negative 12 adds to be a 1? It's this. So the x minus 3's and the 3 minus x's cancel out almost. They make a negative 1 somewhere. Where you stick the negative 1, most people like the middle. So they'll say 3 plus x on top, x plus 4 on bottom, remembering that there's these invisible parentheses around the numerator and denominator. Questions? All right, let's take about a 5-minute break. Come back about 8:01. All right. From chapter 1 and from exam number 1, I think there's a problem that was something like, it was something like this. After several steps, it looked something like this. Okay, I think it was problem number 2 or something. Whatever, you can look at it. And the problem became the absolute value of negative 7 is 7, but the problem became negative 5 plus 5. So we had 7 over 0. And you are never allowed, okay, even if you go to the highest levels of mathematics, they do not allow 0 in the denominator. Now, they have different ways of handling it, okay? There's all kinds of tricky ways, but the basic idea is you can't have 0 in the denominator. It's called undefined. Okay, sometimes mom used does not exist or something like that, but it's undefined. Just absolutely can't be done. 0 in the denominator. Well, okay, in chapter 8.1, okay, elementary, we're going to give you a fraction like that and ask for what values of x is the fraction undefined. Or it'll say find the values of x so that the fraction is undefined, or something to that effect. Well, okay, the key here is an undefined fraction means the denominator can't equal 0. That's what I just erased that. So how do you handle it? You take the denominator of this problem and you simply write a non-equation. Just, you say, whatever that is, it can't equal 0. And then you solve it, add 4 to both sides. X can't equal 4. This is called the restriction on the domain. Remember, domain is all possible x values. Well, for this problem, x can be everything in the universe, anything you want, except for 4. Because if x were 4, it would make that denominator 0, and that would make your fraction undefined. So you're literally finding what causes the problem to blow up. How do you do it? You take the denominator and you say the denominator cannot be worth 0. And you solve that problem. And that answer is called your restriction. Think about when you were a teenager and you were put on restriction. Okay, you couldn't do things. You couldn't call your friends. You couldn't go in the car. You couldn't go on a date, whatever. You were restricted. You couldn't do things. Okay, so in this problem, X can be any number I want it to be, except for 4. It's restricted from 4 because 4 will cause the denominator to blow up. So let's take a couple problems with that. Oh, common question. What about the 5x plus 3? Nothing. It's got nothing to do with this question because undefined fractions are for the denominator. Okay, so I almost guarantee a problem like this when we get to the chapter 8 test. I'll give you something like this and say, what values make it undefined? Find the values of X that are undefined or that make it restricted. And most of you will work with the denominator. A few of you I will trick and you'll work with the numerator, and that's wrong. The numerator has nothing to do with undefined fractions. So let's take this one. Example. 3x plus 7 over 2x minus 5. And another example, x plus 4 over x squared minus 9. Yeah, okay, that's cool. So for each of those, find the restrictions. Find the values that would make it blow up, make the denominator blow up. Okay, so give that a try. My dog is barking. I'll be back. All right, so the top one, pretty easy. You just take the denominator and you say it cannot be worth 0. You kind of create a non-equation out of it, but you solve it just as if it were an equal sign. Okay, so you add 5 to both sides. 2x doesn't equal 5. Divide by 2. X doesn't equal 5 over 2. So that would be called the restriction. X cannot be 5 over 2 because if it were, it would cause that denominator to be 0, which would cause the entire fraction to be undefined. Okay, again, numerator had nothing. Okay, coming down to this one, we say, oh, x squared minus 9 cannot equal 0. Okay, but that's a dose. So that's at x minus 3, x plus 3. Okay, again, pay attention. This one up here is called a linear equation. It's what we studied in chapter 2. It's just get x alone. This was called a quadratic or a power equation. Got a power of 2. This is what we studied in chapter 7. And the only way to do it with a power is to factor it. So this is why all that chapter 7 stuff was super, super important. So you factor this. Oops, doesn't equal 0. You split it up. X minus 3 doesn't equal 0. Or x plus 3 doesn't equal 0. So we get x doesn't equal 3. X doesn't equal negative 3. Some of you have seen this before. People think they're tricky because they write x does not equal, they say plus minus 3. That's just a trick way of saying positive and negative 3 at the same time, okay, instead of writing it down twice. I don't really care which method you use. So those are called restrictions. And for a fraction, the restriction applies to the denominator only. You take the denominator, you say it can't equal 0, and you figure out how to solve it. Okay, if it's linear, you get x alone. If it's a power equation, you factor it somehow. That okay with everybody? You guys need an extra one more problem, or can we move on to kind of like the last topic of the night? Anybody need an extra example of that?
Can we do one more problem?
Sure. Again, the instructions are going to be find the values that are undefined, or find the restrictions. They kind of mean the same thing. Find the undefined values for x, find the restrictions. So 3x squared plus 2x minus 7 over 5x squared minus 10x. So find the restrictions for this fraction. Find the restrictions. I'll pause it. Okay, so again, restrictions say the denominator cannot equal 0. So you take the 5x squared minus 10x and say it cannot equal 0. And then you study that and ask, how do I solve that? Mentally, you just simply pretend it's an equal sign. How would you solve it if it were an equal sign? Okay, and just say, okay, it's not equal. That's all you do. So here you look at that and you go, oh, it's a power equation. I factor it. I can take out a 5x. That leaves x minus 2 cannot equal 0. Okay, I can't factor any further, so I separate it. I say either 5x can't equal 0, or x minus 2 can't equal 0. Divide both sides by 5, x can't equal 0, or add 2, x can't equal 2. So our restrictions are x can't, we put them all back together, can't equal 0 or 2. That's our answer. X can't equal 0 or 2 in this problem. Again, the numerator had nothing to do with the problem, not with the directions. Remember, the directions I gave you verbally were find the restrictions on x, or find the undefined values. This fraction will be undefined if x is 0 or 2. Is that okay with everybody? Okay, there's enough problems in MOM, and you guys can try those and come back and yell at me, and we'll work it out. I've given you probably about 99% in section 8.1 of what you need. There's a few tricks in there, but I want to get onto other stuff also. So, new stuff. Still in chapter 8. Okay. With no calculator at all. Okay. I want you, no calculator, no cheating, to figure this problem out. 27 over 32 divided by 75 over 40. Okay, I'll pause. But what I want to show you is a couple things. First off, how do you divide fractions? Well, we've been taught to leave the first alone 27 over 32, change this to a multiplication and flip this one over. That's what we've been taught. Okay, and it's still correct. So we're going to divide fractions. We leave the first fraction in its normal form, whatever it was, change the division symbol to a multiplication symbol, and flip over the second fraction. Yours is not to question why, just invert and multiply. That's how I was taught. Now, no calculator. Oh my God. Well, here's one method. It's not the only way, but it leads to what I want to show you in our algebra class. Instead of 27, you could think of it as 3 times 9. It's still 27, okay? Instead of 32, you could think of it as 4 times 8, okay? Times. Instead of 40, you could think of it as 5 times 8. And instead of 75, you could think of it as 3 times 25. Okay. Right now, you can do what we called cross cancel. Okay. For example, this 8 and this 8, those are factors. And they're exactly the same. I can cancel them out. Okay. This 3 and this 3, those are factors. I can cancel them out. So suddenly my big ugly problem became on top 9 times 5 and on bottom 4 times 25. Not quite so ugly. And all I did was think of my multiplication tables. I factored them. 27 became 3 times 9. 32 became 4 times 8, and so on. Well, wait a minute. I can do some more. I'm on a roll here. For example, this 9 times 5, that's cool, but 4 times, check it out, 25 could be 5 times 5. So I can still do some more cross canceling. The 5 and the 5, cross out. I'm ready for my final answer. On top, I only have a 9. On bottom, I have 4 times 5, which is 20. And there's my answer. And I did not use my calculator. I just used my basic multiplication skills. That's it. Now, what's this got to do with you guys? Well, this was an arithmetic fraction. Remember, I started talking about arithmetic fraction, just as numbers in it. In a few minutes, we're going to do the same kind of problem, but with an algebra fraction, or actually 2 fractions. Okay. And the steps are going to be identical. If it's division, we're going to flip over the second fraction and write it as multiplication. But instead of going through my times tables here, I'm going to factor. I'm going to factor everybody and their mother. Everybody's going to get factored. That sounds wrong. Okay, factor everybody. Factor you. No, never mind. Okay. So here we go. In terms of steps, we're in chapter 8. Chapter 8.2. And let me double check. Yeah, 8.2. Okay. We are going to multiply and divide rational expressions okay, and first, if it's division, we're going to change to multiplication, and we're going to flip. Same thing we did here. Secondly, we're going to factor completely. And remember, this is algebra. So when I say the word factor, I mean factor what they have in common. Dose, trinomials, grouping. You're going to do all of those. Okay, all of those are fair game. So that one word factor means do a whole lot. Okay. Third, we're going to cancel exact same factors. Okay. And I'm going to put a little hint here. Don't forget the -1, oops, trick. Okay. And lastly, and this is a little bit weird, fourth, we're going to re-multiply numerator and we're going to leave denominator factored. And I will show you what I mean when I say that. So first, if it happens to be division, we can change it to multiplication and flip. Second, we're going to factor everybody completely. Third, we will cancel exact same factors. That's exactly what we did in chapter 8.1. And we have the -1 trick from 8.1. But then when we're done, we're going to re-multiply the numerator. And I'll show you, but this is important. And look at my, I think I'm cute, okay? We're going to leave the denominator factored. In other words, if you've got a bunch of parentheses in the denominator, just leave them there. Don't multiply them together. Leave the denominator factored. Okay. All right, so here we go. So number one, 5x minus 5 over x divided by 10x minus 10 over 3x to the second. Okay, I'll walk you through this one, and then I'll give you guys a few to try. So this is going to be 5x minus 5 over x multiplied by 3x squared over 10x minus 10. Okay, so that's the division part. Change the division symbol into multiplication, flip the second fraction. Okay, now we look to factor. And I hope you're paying attention to this because this actually has a trick. So this is 5 times x minus 1 over x. This numerator here, we can take out a 5. Remember, when you divide out the 5, you leave a 1. Taking out actually means divide. Times. Now, this is where the trick shows up. When we say 3x squared, it's 3 times x times x. That's important. 3x squared means 3 times x times x. You'll see why it's important in a moment. The denominator, take out a 10, that also leaves x minus 1. Okay, so now who cancels? Well, clearly the x minus 1s cancel. Yay for that. Okay, but also one of these x's cancels. Doesn't matter which one. Okay, that's why you separated the x squared, x to the second power, as xx. So you can see that one of those x's and that x down there cancel out. So what do we have left? On top, we have 5 times 3 times x. 5, 3, and an x. On bottom, we have 10. Well, wait a minute. Can I break up 10? Sure. 10 is 5 times 2. So this 5 and this 5 cancel out. Shove everybody back together. Final answer, 3x over 2. The fourth step didn't apply to this problem because there's only one thing in the denominator, a 2. Pretty much that's it. Okay, change division into multiplication. Factor everybody as much as you possibly can, including the x squared. Including the x squared. Factor everybody. Cancel exact same factors. This didn't have the -1 trick. I'm not sure I'll throw that at you tonight. We'll see how it goes. But it didn't have that. And get a final answer. Questions? Okay, then I'll have you guys try this one. Okay. X squared plus 2x over x minus 1. Gotta erase this. Sorry. Divided by x cubed plus x squared over x squared minus 1. Okay, so x squared plus 2x on top over x minus 1 on bottom. Second fraction, x to the third plus x squared minus 1, and it's division, and I'll pause while you guys work through this. Okay, so first one, I can factor out an x, leaving x plus 2 on top. The denominator, nobody factors, nothing happens, so there's that. Times, okay, I shouldn't have done it this way. X squared minus 1 over x cubed plus x squared. Shoot. Okay. So I should have flipped it first, but I'm going to get there in a second. Okay. After flipping the second fraction, x squared minus 1, this is a dose problem that a lot of people screw up on, and I'll be happy to show that to you. X squared minus 1 factors into x plus 1, x minus 1. A lot of people get all confused about that. I'll be happy to show it to you if you need. Factor an x squared out of the bottom, leaving x plus 1. So let's pause there for just a second. That's my factoring. Okay. The numerator factors to here. This denominator, I'm pointing two places simultaneously, didn't factor. I flipped the second fraction and then factored it. I have a dose, x squared minus 1 on top and an x squared times x plus 1 on the bottom. Any questions about my factoring? Anybody want an explanation or want me to slow down or show how I did something?
I have one question.
Yeah,
Couldn't you still factor the x square?
yeah, you could. Yeah, you could. And most people don't see it right away. If you see it, great. We're not done with that, but yes, good call. Anybody else? Okay, so who cancels? Well, for example, remember this x minus 1 has an invisible parenthesis around it. So this x minus 1 and this x minus 1 cancel out. Who else cancels out? Well, an x plus 1 and an x plus 1. Those cancel out. Now, the comment was, I'm going to rewrite this as an extra step. On top, I have x times x plus 2. On bottom, I have x squared, but just as I did over here, I could take the x squared and break it up into x times x. Oops, and I'm right in the middle of the glare. Good job. Sorry. So on top, where am I? Glare is right about there. Okay. I have x times x plus 2. On bottom, I have x squared, but I write it as x times x. Okay. So this x and one of those x's go bye-bye. So final answer is going to be x plus 2 over x. Okay. The temptation is you guys try to cancel those x's. You cannot, because that x plus 2 is still implied to be a quantity. So if you want to cancel that x plus 2, it's got to be with the whole thing, x plus 2. You can't go any further. Now, there's lots of places where you could have skipped steps. Pretty much that's it. We doing okay? Kind of getting the hang of it a little bit. I hope. Okay. All right.
Question real quick.
Yeah,
Sorry.
That's okay.
Can you just leave the x plus 2 in parentheses and
Sure.
won't get docked? Okay.
you won't get docked at all. Another instructor in a future class may ask you why you're doing that. And your answer is, I'm trying to remind myself that it's still a quantity. Okay, and they may look at you weird and they may say, well, I don't like it, but it's not wrong. So yes, you can.
Yeah.
Okay. All right. Anybody else? Good question. Is everybody okay with how I factored x squared minus 1 into x minus 1, x plus 1? That's a dose factoring, the easiest one possible, but it's also the trickiest. All right. Oh, how can I ruin your life? Okay. I will pause right now. Okay, so we want to, all right, I don't want to skip too many steps here, at least at the beginning. But I do want to write neatly. Times, this is going to be xy minus y over 3y. Okay. Factor, like we talked before, y squared can be y times y. I'm not sure it helps me in this one, but we'll see. X plus 1 stays x plus 1 times. Okay, I'm going to jump to the answer again. If you need me to explain how I got that, I'll be happy to. Whoops, especially if I can do it wrong. So y squared, I separated as y times y. I don't know why. That was a joke, pun. X squared plus 2x plus 1. It's a trinomial. I used AC and easy factoring and got x plus 1, x plus 1. And I'll be happy to show that if you need it. X squared minus 1 becomes x minus 1, x plus 1. Remember, it doesn't matter who you write first, as long as it's one's a plus 1 and one's a minus 1. It doesn't matter who's first, whatever. Factor out a y in common. Leaves a 1 there, and 3y means 3 times y. So there's my factoring. Anybody have any questions on my factoring? Okay, so who goes? Well, let's see. Shoot. This x minus 1 and this x minus 1. There you go. This x plus 1 here with the invisible parenthesis and one of these x plus 1s. Now, a lot of people balk at this. We can cancel those out. It's just anybody on top with anybody on bottom, same factor. So we can cancel those out. They're gone. Okay. Now I got y's up the yin yang, so I don't know who's going to get. I guess I'll just cancel these two. So if I put everybody back together, what do I have? I got y times y on top. So I got y to the second on top. On bottom, I've got a 3. There's my answer. I'm done. Questions? You're sure?
I do.
Okay, go ahead.
Why are we doing this?
You're learning how to manipulate fractions, okay? Because you're going to get the same thing in trigonometry, but you're going to get something like sine squared plus 2 sine plus 1 over sine squared minus 1. So you're going to get, from my point of view, this problem and this problem right here are exactly the same. They're exactly the same. Instead of being x squared plus 2x plus 1, I wrote sine squared plus 2 sine plus 1. They're exactly the same. And we want to learn how to simplify. These are called trigonometric expressions. So we'll learn to factor this. This will become sine plus 1 sine plus 1 on top. This will become sine minus 1 sine plus 1. and you'll learn to simplify all stuff. Okay, why are we doing this? Because when you get to calculus, I don't know if you've seen anybody write what's called an integral like this. Okay, and you'll see something like this. They'll write that, or they'll write this with sine. Remember, it's not sin, it's sine. And they'll ask you to perform this calculation. And you can't. But if you simplify this into, if you reduce this down into the integral, this will become, after you factor it, after you do some factoring, okay, this problem can't be done, but if you factor and cancel it, this problem can be done. It's still tricky, okay, but this is impossible. This is doable with some extra trickery. So why are we doing this? We're doing this for practice, okay, in the simplest possible way, because you're going to be constantly bombarded with these in your future math classes. Remember also the first thing I said in this class leads to calculus. The only reason you're in this class is because you're a STEM major and you're ultimately going to be taking calculus. So what we're doing here is providing the foundation for what you're going to end up with in calculus. Now, that may not be a satisfactory answer, but that's about the best I can give you right now.
No, that's actually really good. I just like to make sense of things. So I'm like, why
Well,
are we doing this?
Yeah, okay, there's an also answer. Did you ask your third grade teacher when you were doing your multiplication tables, why are we learning this? No,
Yeah.
not really. I mean, because number one, you were intimidated, okay? But without those fundamental skills, or even your addition subtraction skills, why are we learning to go 7 plus 3 is 10? Who cares? But those become the fundamental building blocks that give us bigger problems that we can work on. So right now, to be really honest, why are we doing this? I don't know, keep you busy, keep you off the streets, don't do drugs, that kind of crap, okay? But these are the building blocks for setting you up for bigger problems in the future, okay? And sometimes that's the best answer I can give you.
That was really good. Thank you.
Okay. Okay, guys, I'm done for the night. Okay, Alt P.